welcome to Biochemistry Basics here. So let's look at this question vividly. The question says, palm wine is a local alternative to regular beer that is sweet and yet alcoholic in nature. The first question says that we should draw the chemical structure in bracket linear and ring form of a named naturally occurring aldohexose that may account for its sweet taste. The second question says that we should draw and name in bracket the common and the systematic name of a reducing disaccharide that can be obtained from the tree where the wine was extracted. And then the third question says that we should state two chemical difference of any two named polysaccharides that can be obtained from that same tree where the wine was extracted. So let's go straight to the answers. So you have to recall vividly that we had earlier described these three disaccharides. We have maltose, we have sucrose, and then we had lactose. So we had earlier talked about these three disaccharides, and we said that maltose is made up of two glucose residues. So we have a glucose and a glucose that are linked together by a glycosidic bond. If you have not watched the video, you can go to our previous videos and look about this disaccharide. We have sucrose, which is made up of glucose and fructose. Then we have lactose, which is made up of galactose and glucose. So these are all disaccharides. Now, among all these three disaccharides that I've listed here, you have to take note that maltose and sucrose, they can be obtained, their main source is from plant or trees. So it's from trees. While lactose, the source is from milk. Milk. So milk, when you hear of milk, you have to think about animals. Are we together? Now, if you have understand this, let's come back to this question. They say we should draw a chemical structure, linear and ring form, of a named naturally occurring aldohexose. Remember, aldohexose, that may account for its sweet taste. Now, which kind of monosaccharide should we be thinking about here? Since we are talking about a tree, so we should be thinking about maltose or sucrose. So for us to draw a naturally occurring aldohexose, so that aldohexose must be glucose, because in maltose we have glucose, which are aldohexoses, and then in sucrose we also have this glucose and fructose, but this glucose here is an aldohexose, but the fructose here is a ketohexose. So that named naturally occurring aldohexose is glucose, because we are talking either about maltose or sucrose. But from the second question I will know if it's actually maltose or is sucrose. But for that disaccharide, that naturally occurring aldohexose is glucose. So we draw linear form. After drawing this, don't forget to give the name, please. So this one is D-glucose, which is the linear form. This linear form is D-glucose. And then for the ring form, you draw this. So this can be either alpha or beta. They are numerical. So this is the ring form of this D-glucose, and the name is, this one is alpha D glucopyranose. Drawing this and giving the name, you end the marks. So we are done with this one. So this is the aldohexose that is found in that particular in the wine. Now the second part of the question says that we should draw and name the common and systematic name of a reducing. This particular part of the question here is very interesting. A reducing disaccharide that can be obtained from the tree where the wine was extracted. Now look at maltose. Among all these three disaccharides that are listed here, we said from our previous video that maltose is a reducing disaccharide. Sucrose is a non-reducing disaccharide because it doesn't have a free anomeric group at the end. Lactose is a reducing disaccharide. Let me just put it here. So this one here is reducing disaccharide. Sucrose is non-reducing, while lactose is reducing. Good. So come back now to this question. Draw and name common and systematic name of a reducing disaccharide that can be obtained from the tree where the wine was extracted. We are talking about tree, so we are talking either about maltose or sucrose. But now the question is talking about a reducing disaccharide. Reducing, meaning that automatically we have eliminated this sucrose because sucrose is non-reducing, while maltose is reducing. So what the disaccharide that is there is this maltose. So they're asking us to draw and name and give the common and systematic name of this disaccharide here, this maltose. Are we together? We should draw and give the common and systematic name of this disaccharide that can be obtained from the tree where the wine was extracted. So I hope it's very clear. So what we are drawing is for maltose. And we said maltose is formed from 2 glucose residues. So this is how it is. First, excuse me. So we have this. So this is where the glycosidic bond is formed. Are we together? Then we have a free anomeric hydroxy group. This is what makes this maltose to be reducing, because it's having this free anomeric hydroxy group here. But for disaccharide, the reducing disaccharide. But now we have now to give the common name and the systematic name. So the common name of this reducing disaccharide, is maltose. Are we together? Then the systematic name of this disaccharide is, let's go together. We have alpha D, because it's obtained from a D glucose, and the hydroxy group of this first glucose residue is pointing down. That's why it is alpha D gluco pyranosyl. Pyran, because it is a 6-membered ring. Pyranosyl 1,4. This is carbon number 1, 2, 3, 4, 5, 6. This is 1, 2, 3, 4, 5, 6. So it's pyranosyl 1,4. The bond is formed between this carbon number 1 of the first glucose residue and the carbon number 4 of the next neighboring glucose residue. So it is pyranosyl 1. The arrow is pointing like this. Remember, 1,4, indicating that the anomeric hydroxy group is from this first glucose residue. 1,4 alpha D again, because it's also from another alpha D glucose. Alpha D gluco pyranose. So we end the name with nose because it is a reducing disaccharide. That's why we end the name with pyranose. Right? It's a sugar, it's a reducing disaccharide. So it's alpha D glucopyranosyl 1,4 alpha D, because it's T from the D glucose and the hydroxy group here is pointing in the alpha direction. In some cases, you will see this one here pointing up. For this OH group, we will be pointing up. So in that case, you put the beta D away together. But for the sake of this video, I put it pointing down. So that's why I'm putting alpha D. Also from another glucose, glucopyranose. So that's the systematic name of that particular disaccharide. So we have given the common name and the systematic name. This is the systematic name here. And then now, the last part of the question says that we should state 2 chemical differences of any 2 named polysaccharides that can be obtained from that particular tree where the wine was extracted. And let me just maybe we'll wipe this. Two chemical differences between any two named polysaccharides. So we are talking about a tree here. So the polysaccharide that we know from a tree, we have starch. Starch is a polysaccharide, which we have seen. Are we together? We have starch and we have cellulose of starch, right? We know starch is made up of amylose and amylopectin. So it's having a branch polymer, branch, for one of its polymers, while this one is a linear polysaccharide. So those are the two basic differences between the two. So thank you so much for watching the video, and if it was interesting, please like, comment and share. I would like to know your difficulties in the comment section. Thank you.